Hi students. Now we are going to derive the relationship between linear momentum of a body and its kinetic energy. Now, what is the expression for kinetic energy of a body whose mass is m and velocity is v? We have already derived. That is, kinetic energy is equal to half m into v square. This is the expression. Now you know that mass is a scalar and the velocity is a vector quantity. So I will take the self dot product of velocity vector. So v vector dot product v vector, this is equal to v square. So v dot v is equal to v square. In place of v square here, I am going to substitute v dot v. Therefore, now what is the expression for kinetic energy is equal to half m into v dot product v. Okay. Now I will multiply the numerator as well as denominator by m. So this is equal to m square divided by 2m. So m into m becomes m square. 2 into m becomes 2m, so that the value does not change, into v dot v. Now mass is a scalar. Even if I wish, I can take the mass into the bracket. So this is also equal to 1 divided by 2m into m into v dot m into v. So this is m into v dot product m into v. Like this also I can write now. But the product of mass into velocity is equal to linear momentum p vector. P is the linear momentum vector. So m into velocity vector is also equal to linear momentum p vector. So this expression, instead of mv dot mv, I can write p dot p. Therefore, I get another equation for kinetic energy is equal to 1 by 2m into p vector dot product p vector. Again, we get a self dot product of two vectors, namely linear momentum vector. So p dot product p is also equal to p square, which is a scalar. Therefore, now the kinetic energy is equal to p square divided by 2m. This is the expression we require. So this equation gives us the relation between linear momentum and the kinetic energy. This is very, very important in the competitive examinations, okay, for solving numerical problems. Now I will write the reverse of this equation here. So p square is equal to 2m times kinetic energy. Therefore, linear momentum is equal to square root of 2m into kinetic energy. So this is another form of the relationship between the linear momentum and the kinetic energy. Both these equations are one and the same, so the representations are different. So either of these two equations you have to remember for solving numerical problems in any examination. I hope you must have understood well. Thank you.